All right, as you can see today, we're just going to be identifying linear functions. Meaning we're going to take a look at a function and we're going to see if it's a linear function. So let's get right to it. Okay, so here's our first example of a function. Now, in order to identify if it's a linear function, I'm just going to make this a little bit bigger. Okay? In order to identify if it's a linear function, what we have to do is we have to make sure that the change in the x values is the same, and the change in the y values is the same. Now, the change in the y values, or the f of x values, doesn't have to be the same as the change in the x, but the change in the y's has to be consistent, just like the change in the x is consistent. What I mean by that is if we look at our values of x, we could see that this is an increase of 1, this would be an increase of 1, this would be an increase of 1. Now, in order for this to be a linear function, when I do the same thing for the f of x, or the y values, I have to get the same change all the time. Now, it doesn't have to be a change of 1, but it has to be the same. So you can see this is going to be a change. I'll be adding 2. This one I'm adding 4. And you can see this one I am adding 6. So clearly this is not a linear function, because if this was a linear function, if the first increase was 2, each of these other increases should be 2. Okay, and let's say that we look at the graph, because graphs don't lie. Let's just take a quick look at our graph. If we were to plot these points, and we'll see what they look like. So let's plot, we have 1, negative 3, so 1, negative 3, that would be over here. Then we have 2, negative 1, that would be this point. We have 3, 3, should be right there. And we have 4, 9, which would be all the way up there. Now, if this were a linear function, which I don't know if you can see that it's not, because sometimes it's kind of tough to see. But if this were a linear function, if I draw a line connecting any 2 points, all of the other points should be on that line. Because remember, linear function means it's a line. Okay, so let's connect 2 points. I'm going to connect the first and the last point. I like to use my straight line tool here. So if I connect these 2 points, okay, you can now clearly see that the other 2 points are not on that line. And it would be the same no matter which 2 points I chose to connect. Like if I connected these 2 points, you could see the other 2 points are not on that line. And if I connected these 2 points, obviously, the other points are not going to be on that line. So that's how we know this is not a linear function from the graph. And I think for a lot of you, the graph is going to be easier to tell than the function itself. Although we're going to do everything we can to kind of fix that. Okay, let's take a look at another example. So here's another function, and we're going to see if this one is linear. So again, if we look at our increase, we could see on this side, on our x side, we are increasing by 1, we are increasing by 1, we're increasing by 1, we're increasing by 1. So this is consistent. So far it's looking pretty good. Now we'll go on the y side, which is the same as f of x, by the way. This is an increase of 2. This would be an increase of 2. This is an increase of 2. And this is an increase of 2. So this one you can see clearly is a linear function. But again, if we wanted to graph it just to kind of confirm that, we can. So let's look at 0, negative 1. That would be this point. Then we look at 1, 1. We look at 2, 3. We look at 3, 5. And we look at 4, 7. Okay, and now, again, if I use my straight line tool, and I connect the first point to the last point, you can see that every point is on that line. So that means this is in fact a linear function. And that's how we identify linear functions. Thanks for watching.